Hi everybody, in this video we're gonna continue the construction of our function for image recognition or image like digit recognition. So we already started. An image is just a block of pixels. What we wanted to do is we wanted to divide this in 4 squares, and we're going to take the sum of all the pixels in the squares. This gives us four real numbers A, B, C, and D. We're in R4. Now where do we want to end up? We want to end up actually in a subset of R10 because we have 10 classes, 10 different digits. So I'm gonna write here 10 dots. 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's give some subscripts. 2 and 1. Because in the end I want to have a 10 tuple with an additional constraint that their sum equals to 1. So this will not yet be the output. Wait for this. And I'm going to use some terminology that you might have heard of. This is actually the input layer called L1 of my neural network. This is my output layer of my neural network. And then we can specify some, they call hidden layers, something you cannot see. And there's always, this is just part of the construction of such a function. You can just choose whichever amount of layers you want. Just gonna give you as an example just one hidden layer L1. Then this is output layer L2. And I want to use a hidden layer, let's say, of 6 nodes. 1, 2, 3, 4, 5, 6. Give me some subscripts here. 4, 3, 2, 1. And what am I going to do now? I'm going to connect the node A to all of these 6 nodes. Going to do the same with the B node. You see it gets kind of messy. Do the same for the C ones and for the D ones. And here also I'm going to connect everything. So node 1 to all the 10 nodes. Not going to draw all the arrows, but you get the ID. And I do the same for all the other ones. This one goes in particular to there, and so on, etc., etc. So really, between every 2 nodes, the 2 consecutive layers, there is an arrow. And every arrow comes actually with 2 function parameters, and I'm gonna. So I have a function parameter which I will call a W with subscript 1 to indicate that it starts from layer L1 and it goes from a node I to a node J. So maybe let me put that here. And also a B1 from IJ, similar here. From layer, this is layer 2, sorry. This is layer 2, this is layer 3, of course, made a mistake here. From IJ and also B to IJ. So what are, first of all, how many of these parameters do I have? Let me write that here. So I have 1 IJ and B1 IJ 4. There are 4 nodes in the first layer, so I goes from 1 to 4, J goes from 1 to 6, because there are 6 nodes here, and the same one here, IJ, B to IJ, and for these guys, I goes from, guess it right, from 1 to 6, J goes from 1 to 10. And I should have given myself some more space here. That will become clear later on. Now, of course, what does this do? This is actually just a schematic overview of a function. Remember, we're still just constructing a function. We started here, a block of grayscale values. We divided it in 4. We took the sum. We're already here. Now, what happens in here? Well, let me denote the value, what I get. So this is from an image we get A, B, C, and D. You can calculate that by summing the grayscale values in the corresponding square. And let me denote these intermediate values here we get by y with the superscript. So in particular, what does this mean? This means, for example, that for let's say k between 6 y of k, this is nothing more than w1 1k times a plus b 1k plus 2k times b 2k plus 3k times c 4k times d plus b1 4k. Because here a you multiply with the w value plus the b value to end up here, plus b multiplied with the w value plus b, and so on and so on. So you do this for all these 6 nodes here. And then if you denote the end values here, z1, z2, all the way to z10, then what is L between 1 and 10? What is the end value ZL? This is just nothing more than the sum from I is 1 to 6, because there's 6 nodes here, W2 IL times YI, which we calculated here, plus this B value here, IL. So what you see, so this is just a schematic representation of this big function, and this is actually all just linear. Basically, it's always multiplying by a weight plus adding another weight. So you see these W's and these B's, these are all these function parameters, or these weights, which we will have to determine during training. Look back at the flow video or the previous examples what we actually mean. So yeah, it's feeding data and doing the gradient descent. But we're not yet entirely finished, because we actually had to end up in this B1 here, which was, well, actually values P1, P10 elements between 0 and 1, such that their sum equals to 1, because we want the probability distribution. So we should go here, and now I'm going to give myself some space here. Give myself some space. I'm going to erase this. There is now a trick, because we're already almost there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And hold this block here is mapped to this here, and this is what we call the softmax. And the softmax of, so the softmax of this 10 tuples of Z1 all the way to Z10, this is just, well, we have a denominator which is the sum of 1 to 10 e to the power, well, you can choose either minus Z1, let's do minus Z1, minus Zi to not, because we're taking exponentials, we know probably that these Z values, they can grow very big, or in general, maybe they will be positive, and then this will gonna blow up. So I'm taking the negative ones here. And so the softmax of this here is just then e to the power minus Z1 over n, e to the power minus 2 over n, and so on until all the way up to 10. And you can see now that these values all lie between 0 and 1, and if you sum them all, you indeed get 1. So we constructed a function that goes from an image being a square of pixels to really a probability distribution. So that's the function. Now what we need is we need training data, labeled data, so really like pictures of a digit with the actual answer, fix all our weights, so all these W's, these B's, fix them, compute the loss, which you know how to do, gradient descent, and repeat until at some point you hope that the loss is below some threshold. Ciao.